Okay, so you've definitely heard the name. You've seen the headlines. Ozempic, right? But the real story? Well, it didn't start in Hollywood. It didn't start on social media. No, this story starts with a venomous lizard, a deep-sea fish, and a scientific puzzle that took decades to solve. This is the wild story of how the hunt for a diabetes treatment ended up accidentally changing, well, pretty much everything. So, late 2022, it really felt like this thing just exploded out of nowhere, didn't it? One word suddenly started dominating every conversation. I mean, Google searches went through the roof, your social media feeds were just buzzing with it. It stopped being just a new drug, and bam, it became this huge cultural flashpoint. And that word, of course, was Ozempic. Think about it. A pretty clinical brand name, right? Well, it somehow escaped the pharmacy and just took on a life of its own. It became a viral hashtag, a meme, a subject of some seriously fierce debates online and offline. And the sheer scale of this thing, it was just staggering. On TikTok, just TikTok alone, the hashtag Ozempic hashtag pulled in over 1 billion views. 1 billion. And this wasn't just online chatter, you know. This viral wave crashed into the real world, creating this incredible demand that literally caused pharmacies to run dry. It got so big the FDA had to step in and declare an official national shortage. Okay, but here's where the story gets really, really weird. The origin of this blockbuster drug, it's not what you'd think. It's not some pristine, futuristic lab. Nope. Its roots are in the venom of lizards and the biology of deep-sea anglerfish. Seriously. So the big question is, how on earth did we get from there to here? All right, to unpack this, we got to jump in the time machine. The story really kicks off in the years after World War II. Doctors started noticing this sharp, troubling rise in a condition that would eventually become one of the biggest health challenges of our time, type 2 diabetes. Now, to really get this, it helps to know the difference between the two types of diabetes. With type 1, you can think of it like the body's insulin factory is just shut down. It's not making any. But with type 2, the factory is actually working fine. The insulin is there, but the body's cells have basically stopped listening. They're ignoring the signal. And that problem, insulin resistance, became the central mystery scientists were trying to solve for decades. So back in the 1960s, researchers stumbled upon something really weird. They found that if you ate sugar, your body produced way more insulin than if you got the exact same amount of sugar injected straight into your veins. Which is strange, right? This led to a fascinating idea. Your gut must be sending some kind of secret hormonal text message to the pancreas, giving it a heads up that sugar is on the way. They gave this a name, the incretin effect. So the hunt was on for that secret message. And it led scientists to some pretty bizarre places. I'm talking from the genes of anglerfish all the way to hamsters. And eventually, they found it. They isolated a hormone called GLP-1. But there was a huge problem. It didn't seem to do anything. It took the absolutely brilliant insight of a researcher named Svetlana Majov to figure out why. She realized the body actually trims the hormone down, and only a very specific, shorter version was the real active key. So this seemed like the holy grail, right? A hormone that intelligently boosts insulin only when you need it. Perfect. Except it had a fatal flaw, a really big one. Our bodies have this enzyme, DPP4, that basically acts like a self-destruct button. It finds GLP-1 and destroys it in about 2 minutes. 2! Imagine finding the perfect key for a lock, but it shatters the second you try to turn it. That's what they had. As a potential medicine, it was completely useless. But that fatal flaw, that's what set the stage for this incredible scientific race. The goal was simple, but the challenge was huge. Figure out how to make this super fragile hormone last longer in the body. And you had 2 competing teams coming at this from completely opposite ends of the scientific universe. And this really became the central question of the 1990s for anyone working on diabetes. How do you do it? Do you go out and find a solution that nature has already made somewhere? Or do you head into the lab and try to build a better one from scratch? So here you can see the 2 rival philosophies laid out. In one corner, the American approach, you've got Dr. John Ng. He's a biologist who decided to go digging through nature's vast library for an answer. And incredibly, he found it in the venom of the Gila monster. Yes, lizard venom. Then, in the other corner, you have the Danish approach, a team of molecular architects at Novo Nordisk, led by the amazing Lotte Bjerre-Knudsen. They decided, forget finding one. We're going to build a better version of the human hormone ourselves. And get this, Both teams had major breakthroughs right around the mid-90s. Dr. Eng found that the version from the lizard venom, called Extendant 4, was naturally tough. It could last for hours, not minutes. Meanwhile, the team at Novo came up with this really clever trick. They basically attached a little fatty acid tail to the human hormone. This acted like a shield, or maybe like camouflage, helping it hide from that self-destruct enzyme. And guess what? Both approaches worked. The lizard venom drug, Byetta, actually hit the market first in 2005, and Novo's designer drug, Victoza, followed it in 2010. But as all this was happening, researchers started noticing something else, a really consistent and pretty powerful side effect, both in their animal studies and in the human trials. People taking these drugs weren't just getting their blood sugar under control, they were also losing weight, a noticeable amount. And that one little observation, well, it was about to change absolutely everything. Now, you have to understand, pivoting to weight loss was a huge gamble. The whole diet drug market was basically a graveyard of corporate reputations. I mean, the very first approved obesity drug was literally methamphetamine. No joke. And more recently, you had the huge fen-phen crisis in the 90s, which linked this popular drug combo to serious heart damage and, of course, massive lawsuits. The whole field was so toxic that Novo Nordisk's own CEO had gone on record saying there was no business for the company in obesity. It was a total no-go zone.
So why did these drugs work so well for weight loss?
Well, the mechanism is actually pretty elegant. Turns out that GLP-1 hormone doesn't just send messages to the pancreas, it also talks to your brainstem. It does two key things. It slows down how fast your stomach empties, and it sends a powerful signal to your brain that says, hey, we're full down here. The result is this really potent, biologically driven feeling of fullness that just reduces your appetite. So, knowing the risks, Novo Nordisk moved very, very carefully. They started up brand new trials using a higher dose of their drug, specifically for weight loss. And their timing, wow, it was impeccable. Because in 2013, there was this seismic shift in the medical world. The American Medical Association officially recognized obesity as a disease. This wasn't just symbolic, it totally changed the game. It created a clear, legitimate path for a treatment. And just 1 year later, in 2014, the FDA gave its approval. The drug was launched under a new brand name, Saxenda. And Saxenda was definitely a success. But it turns out it was just the opening act. Because back in the lab, using that same fatty acid technology they pioneered, Novo Nordisk created an even better, even more potent, once-a-week version. They called it semaglutide, and it would get two brand names, Ozempic for diabetes and Wegovy for weight loss. And this was the drug that was about to ignite an absolute firestorm. Just look at this chart for a second. It's astonishing. The launch of Wegovy wasn't just a success, it was a full-blown phenomenon. To put it in perspective, in its first 5 weeks on the market, Wegovy got more prescriptions than its predecessor, Saxenda, did in its first 4 years. Let that sink in. 5 weeks versus 4 years. Absolutely nobody in the industry was prepared for that kind of explosion in demand. So what was the game changer? What was different this time? Well, one word, TikTok. Social media completely transformed a prescription medication into a viral consumer product. This time, the marketing wasn't coming from those glossy TV ads you see from pharmaceutical companies. No, it was coming from thousands of seemingly authentic videos of real people sharing these jaw-dropping before and after transformations. It was digital word of mouth, but supercharged to a global scale. And this tidal wave of demand just completely overwhelmed a supply chain that was not ready for it. The shortages got so bad that they triggered this old kind of obscure rule. It allows special compounding pharmacies, think of them like small batch custom drug makers, to legally mix their own versions of a drug during a shortage. And this just opened the floodgates to a whole gray market of copycat drugs. The problem was, many of them were using different chemical forms of the active ingredient, forms that the FDA explicitly warned were untested and potentially unsafe. And believe me, the innovation is not slowing down, not at all. A rival company, Eli Lilly, has already launched dual agonist drugs, which are even more powerful because they target 2 different hormones at once. Now there are triple agonists in trials. And the real holy grail, a simple, effective pill you can just swallow, that's getting closer and closer. This race is only getting faster. So when you step back and look at this whole insane journey, A few key things really stand out. First, this is just an amazing story about scientific creativity, about how you can solve the same problem by taking two totally different paths, one through nature and one through pure design. Second, timing was everything. These drugs hit the scene in this perfect window, long after the old diet drug scandals had faded from memory, but right at the moment TikTok was creating a brand new kind of marketing machine. And finally, the sheer financial success of these drugs has totally reshaped the entire pharmaceutical industry. The hunt for even better weight loss drugs is now the industry's new gold rush. And all of that leaves us with a pretty big, fascinating question to think about. I mean, these drugs were born from this long, difficult quest to treat a serious disease. But their incredible journey through science and then through culture and social media has turned them into something else entirely. It really forces us and you to ask, what happens when a treatment for a disease becomes the most popular solution for a very common human desire?